Have you ever felt like a software solution was way more complex than actually required? This problem is commonly known as overengineering, and today I want to talk about this common issue a bit, so maybe you can understand it in a better way. Now, as tech professionals, we really like clever and powerful solutions. Me as a software engineer, I take a bit of pride in actually using my logical brain to build complex and powerful software solutions, and that is pretty normal, I think. In some cases, this tendency can actually go too far, and we have to be aware of it, because otherwise we are causing damage to a project. Because when you go overboard with building a really powerful solution, it can quickly become over-engineering. Now, why is over-engineering a problem? First, let's have a better definition here. Over-engineering, when I refer to it, is making a solution far more complex, feature-rich, or high quality than is actually required by the customer. So when we go overboard with these things, it's not free. You might say, okay, when I buy a product and I get something that is way more capable and high quality than I expected, that's a good thing, right? Because my expectations were exceeded. So what's the problem? The problem is it costs much more resources than was actually needed. So the time, the money, and the energy that we spend on unnecessary bells and whistles could have been directed towards other purposes. It's basically an opportunity cost. We could have used that for other software projects or for ourselves or for other needs of the customer or whatever. That's the core problem. And in addition, it can introduce follow-up issues, like it's harder to maintain the software in the future because it's more complex, so additional costs will arrive in the future. And also you may experience a lack of trust with your stakeholders because you took longer or more resources than was actually planned. So that's another issue in addition to the money cost. So now that we are aware of the problem, how can we detect over-engineering? And again, awareness is the first step, so we can actually improve. And while there's no golden way of detecting over-engineering, I want to share a few example hints from my professional experience for detecting those over-the-top efforts. Number one is when you add features that have never been discussed with stakeholders, maybe just because you think it might be needed in the future. I've heard that a lot. And of course, I'm not completely immune to it. Sometimes when I'm working on the software, I also think, this other feature that comes to my mind that would be really helpful for the user. But then I stop myself and I don't go ahead and build it right away. I just make a note and then discuss it with someone from the business side if it's actually a good idea, if they want to plan this, prioritize it, and so on. Or maybe they say, no, actually, we don't need it. Thanks for the idea, but it's actually not that useful for us. Number two is another telltale sign when you have tons of configuration options that are likely never going to change. So there's nothing wrong with configuration. Flexibility is great. But when you add configuration options, just because you might need them, it might be good to be flexible, or you want to avoid code changes, you want to specify everything with configurations, it might be a sign that you're actually doing over-engineering. Ask yourself which flexibility is actually needed in the near future, and then you can add additional configuration later because it comes with a cost. You have to make sure those switches are actually working, test them, document them, and so on. That is not for free. Number 3 is when you choose a really complex, scalable architecture pattern, but your application is actually quite limited in terms of the overall scope and the user count. So sometimes you have a situation where microservices make sense, or an event-driven system where you have a large distributed network of services which are communicating with each other and so on. Sometimes that makes sense. But maybe you're just building a simple single user application. Maybe it's a command line application or a desktop application. Maybe the feature set is really limited, or you don't really need to scale because you won't have more than 10 users because it's used internally by a company and not rolled out to the public. Then it can be a sign of over-engineering when you go for a microservice architecture by default or something like that. Be aware of that. Number 4 is when you apply very generic programming concepts to prepare for potential future changes. So that's a bit abstract, but it basically means that you make your code base very abstract. You have a lot of abstractions. You have something like very, very general concepts that you apply in a way that you want to avoid repeating code at any cost. Maybe you write yourself a code generator, things like that. So really generic, powerful stuff, but you're only doing it because it might be useful in the future, but you don't need it right now. You are afraid of repeating code, having a bit of duplication, or you're afraid of having to do refactorings in the future. You don't want to touch the software that much again in the future, and that's why you're trying to predict what kind of changes are going to be needed. But those predictions, from my experience, are usually not accurate. So I would avoid it and introduce the generic approach and the abstractions when you need them. Number 5, the last one, is when there's some insisting on something like perfectionism, like let's say 100% test coverage. Yeah. When you're building something like a prototype or a proof of concept, MVP, something like that, of course there's nothing wrong with testing and adding tests. That is generally useful. But in this case, you probably don't want 100% test coverage. Most projects don't need 100% test coverage because it's either not needed or not useful. So in those cases, you should be aware that you might be going overboard and investing effort that is actually can be better spent otherwise. So that was it. What is your opinion on over-engineering? Have you experienced it in your day-to-day IT life? Please tell me in the comments.